still basically halogenoalkanes. So in halogenoalkanes, what other reactions you've got? You've got another reaction which is known as elimination. ठीक है, एक second मैं वहां तक पहुंच जाऊं. अच्छा, so there's this other reaction. So we did what did we do? We did क्या था? We did the mechanism, the substitution thing. We did how halogenoalkanes got formed in the first place, and primary, secondary, tertiary halogenoalkanes. Primary underwent SN2 mechanism. That's what we did. Where I told you that where I told you okay, the nucleophile gets attracted to it and the Cl gets knocked out, or the halogen gets knocked out, and the other one is okay, where a carbocation gets formed first. Okay, and then we discussed why SN1, SN2. Okay, we talked about that as well. So now what we're going to talk about is we're going to talk about the speed of reaction. Okay, so reactivity of halogenoalkanes. Now, when you talk about the reactivity of halogenoalkanes, then the bigger atoms, so bigger atoms, they tend to have weaker bonds. So iodine is going to be the least, it's going to be the most reactive halogenoalkane, followed by RBr, and then followed by RCl. R is the carbon chain. So this is going to be very reactive. So its reactions are going to be fast, and this one over here is going to be the least reactive. And the answer to that is, okay, why is it less reactive? Because it's got a very strong bond. Smaller atoms, remember, smaller atoms, they make stronger bonds. So whenever you have smaller atoms, they make stronger bonds. And the reason they make stronger bonds is that I mean, smaller atoms would be closer together, so there's going to be more attraction. The shorter bond length. So the closer they are, the stronger is going to be the attraction. There's going to be more orbital overlap. So there's going to be more orbital overlap, and there's going to be less shielded nucleus as well. So a less shielded nuclear as well. So is this clear? Chloroalkanes are going to be less reactive. Iodoalkanes are going to be very reactive. Okay, is this part clear?
जी sir.
So there's a reaction called elimination reaction. Now, what happens in elimination reactions is so what happens in elimination reactions is that you've got a halogenoalkane, and the halogen gets eliminated. No mechanism required. You just need to know okay, the halogen is going to get eliminated. So if you have H and another H, so what will happen is okay, the H is going to get The Cl is going to get eliminated. So you've got a Cl. And the H from the neighboring carbon atom might get eliminated. So it could be the right one or the left one. So it could be either side. So you're going to get, what you're going to get is you're going to get two products. And both of them will be alkenes. So you're going to get two different products. So either the H and Cl over here, not this one, the H and Cl over here, they get eliminated. Just a second. So either it's going to be H and Cl over here getting eliminated, and you'll have an alkene getting formed. Okay, that's one of the products. Or what can happen is that the H and Cl over here can get eliminated. Not that one. Okay, so you'll get a double bond over here. The only byproduct of this reaction is going to be an HCl molecule. In both cases, an HCl molecule is going to get produced. So these are going to be your two products of elimination. ठीक है, is this clear?
Yes.
और इसके लिए जो conditions are, that's NaOH, ethanolic, and reflux. ठीक है, so it's going to be NaOH and ethanolic, and reflux. ठीक है, that's the conditions that are required for elimination. Now there's a condition of nucleophilic substitution which is very similar. जैसे यहाँ पे ना nucleophilic substitution के अंदर you use NaOH aqueous and reflux. In that case, substitution happens. The OHN comes in and the Cl gets knocked out. ठीक है, so remember NaOH aqueous and reflux, that's substitution. And NaOH ethanolic, that will give you elimination. Ethanolic means the solvent is ethanol. ठीक है, अच्छा वैसे मैं reference के लिए So later on, I'll share this sheet as well. There's a chart, a reaction chart. I mean, the way you're going to remember all of this, ठीक है? किधर है AS? तो यहाँ पे ना there's this best AS organic revision chart. So this chart pretty much has all the reactions on one page. अच्छा, तो अभी हम कहाँ तक पहुंचे? We have reached halogenoalkanes, which was where's halogenoalkanes? It's over here. So we did all of the reactions. Okay, how do you form it? Alkene bromination, hydrogen halides. We did NaOH or KOH elimination plus heat. You get an alkene back again. Free radical substitution of alkanes would form a halogenoalkane. Then you'll have NS nucleophilic substitution, SN1, SN2, and you'll get an alcohol. You'll get a nitrile, and you'll get an amine as well. Okay, so we did kind of finish all of the reactions over here. So next we're going to move towards alcohols, all of these reactions. But before that, there's still some stuff left. One is how do you identify एक identification से चीजें related है. So identification of halide. So identification of halogen in halogenoalkane. So how do you do that? So the way that's done is now any halogenoalkane, let's say X is the halogen, some of the halogenoalkane will on its own ionize. Very little of it. I mean, the halide will probably will probably break off. Okay, where X can be any of the halogens. It could be Cl, it could be Br, it could be I as well. Okay. So randomly during collision, some of the halides can actually break down. So how do you identify a halide? You're going to add silver nitrate. तो अगर तो वो Cl-1 है, it could be the halide could be Br-1 or it could be I-1. ठीक है, so all three possibilities. तो in O levels you did these tests already. Okay, what's the test? You add aqueous silver nitrate. So add aqueous silver nitrate. Then in all three cases, you're going to form a precipitate of over here. It's going to be AgCl, solid precipitate. That's a white PPT that's going to be formed. फिर वहां पे क्या? It's going to be AgBr. That's going to be a white. That's going to be a cream precipitate. And then you're going to have AgI, which is going to be a yellow precipitate. You test of anions, cations in IGCSE or in O levels. You did these tests. Okay, so the first one is you add silver nitrate. So once you've added silver nitrate, the next thing you're going to do is you're going to try and dissolve in ammonia. To confirm. So the first one dissolves in aqueous ammonia. अच्छा फिर next one, it is harder to dissolve, but it dissolves in concentrated NH3. And the third one does not dissolve. Basically, the precipitate does not dissolve. It's an insoluble precipitate. ठीक है, तो ये आपका ना identification of halide, ठीक है, in the halogenoalkane. You can just use this, ठीक है. So is this clear?
जी सर.
Yes.
अच्छा फिर एक है कि uses like where do you actually use them? So uses of halogenoalkanes. Now, when it comes to uses of halogenoalkanes, what will happen is they're used in a number of places. Okay, so you use them in CFCs. ठीक है, तो CFCs पढ़ लेते हैं, उसकी poisoning वगैरह etc. everything. ठीक है, so they use in CFCs, number one, which are chlorofluorocarbons. So now CFCs are kind of like very very important compounds because they are inert solvents, very inert, and they're very volatile as well. So CFC is this thing that it's got carbon with fluorines and chlorine. So you can have a bunch of carbon atoms with bonded with fluorines and Cls. Bonded with fluorines and Cls. Now, one thing is this, and volatile, they're also known as, so they're used as solvents. Industry में they're used as inert solvents, volatile, so they're used as मतलब लिख देते हैं क्या क्या, so solvents, they used as coolants. They're also sometimes referred to as freons. Anesthetic. Anesthetics are made from CFCs as well. That it's a word chloroform. Just a second. Like chloroform is a color. अच्छी तो वैसे poisonous कह रहा है. Just a second. We chloroform. I just wanted to figure out what the structure of, what is the structure, chemical formula of chloroform. ये वो अक्सर ना वो उसमें movies के अंदर ना when they are kidnapping someone, so they apply chloroform to it, to a piece of cloth. अच्छा खैर ये इसका फॉर्मूला मैंने देखा था just very quickly. This is chloroform. ठीक है, see it's trichloromethane. अच्छा, so that's CFCs, anesthetics, coolants, refrigerants, perfumes वगैरह के अंदर भी use होता है as aerosols. अच्छा फिर there's remember bromine के बारे में एक है कि bromine related compounds are used as fire retardants. ठीक है, so you can have, most fire retardants are actually bromine related compounds. I said those are not really, I mean, if it's bromine, that's not a CFC. ये fire retardants का ना ये formula होता है fire. ठीक है, for example, that's like a fire retardant. ठीक है, that's a molecule that's used as a fire retardant. ठीक है, so fire retardants are bromine related compounds. What else? I guess that's it, CFCs के लिए. ठीक है, now there's अच्छा second, some other stuff, बल्कि actually second होगा. अच्छा, some other stuff related to this, they're also used in polymers. Polymers such as PVCs and Teflon, which is PTFE. ठीक है, they help to make the molecule polar, so the attractive forces increases. So PVC is used as a construction material for pipes or tiles, etc. Teflon is used as a non-stick in cooking utensils. ठीक है, so I guess that's it. Achha, so that's like the uses of halogenoalkanes. And so remember, why do we need CFCs? Because water is a very bad solvent. I mean, water is an extremely bad solvent. Why? Because water is extremely reactive. ठीक है, so it's so reactive that अगर आप water को use करोगे ना, like if you use water in your ACs or as a refrigerant, it will corrode all of it. It's so water is an extremely bad solvent because it's very reactive. You want a solvent that is kind of unreactive, so that's why CFCs are very good. अब ये कि CFCs का harmful effect भी है. So let's discuss the harmful effects of CFCs, that it destroys ozone. As a harmful effect of a CFC, destroys ozone. And how does it do that? Okay, first thing is that free radicals, they get produced in the upper atmosphere due to strong UV radiation. So you get a lot of free radicals, and in upper atmosphere, not in the lower atmosphere. They're fine, there's nothing wrong with them. But because they're volatile, they'll probably end up reaching the upper atmosphere. They've got low boiling points. So when they reach the upper atmosphere, तो वहां पे what happens is कि there's strong UV radiation. And if you have a CFC, like you've got a molecule which has Cl, maybe an F, maybe another Cl. ठीक है, let's say that's a CFC. तो आपका जो molecule है, that breaks down homolytically, that the bond will eventually it's going to break homolytically. And when homolytic bond fission happens, normally it results in the formation of radicals. So you'll have two radicals that will be produced. One will be a carbon radical, and the other one is going to be a Cl. It's going to be a Cl radical. Okay? These two radicals get produced. Now radicals are very reactive. So so the Cl radicals, which are then produced, they start attacking ozone. Which is O3. That's what ozone is. So when they attack the ozone, they destroy it. So Cl radicals क्या करेंगे कि the bonds are not complete. So what they're going to do is they're going to steal one of the oxygen atoms. So they're going to become ClO, and O2 gets formed. Now ClO, the oxygen is now a radical, okay, because its bonds are not complete. So this ClO radical then goes and attacks another ozone molecule. And when it does that, it's going to form two O2 molecules now. And the Cl radical gets formed again. So one Cl radical will continue to destroy a lot of these ozone molecules. Okay, it's going to be an endless destruction of ozone. Ozone is necessary. Why is it necessary? Because ये haze-like substance है, जो smog होता है ना cars की वजह से, that is actually ozone as well, because ozone is pretty harmful for human beings. So lower atmosphere, it's not a good thing. Upper atmosphere, it's a good thing. So it's so ozone, okay, that's the fog-like substance, reflects harmful UV rays. And so it should be destroyed, ठीक है? तो बस ये. तो ये सारा clear है?
जी सर.
Yes.
चलो अब इसके अब I guess वो खत्म हो गया मेरे ख्याल से ये halogenoalkanes, ठीक है? We'll just have a look at the end. So the next thing is alcohols. Or alcohols, let's do some properties of alcohols. ठीक है? What do alcohols do? so alcohols. First thing is, an alcohol is something that's got OH in it. Okay, so it's a carbon chain, and you can have an OH. You can have multiple OH groups. Okay, so it's got a hydroxy group. Now, since it's got a hydroxy group, as if you've got a hydroxy group. Now, the first thing about this hydroxy group is that it's going to have number one properties is key. It's going to have high melting and boiling points. क्यों होंगे इसके high melting and boiling points? राफे अहमद.
Sir, hydrogen bonding की वजह से.
ठीक है, so it can form hydrogen bonds, and that's why it's going to be very soluble in water as well. So it's going to be soluble in water as well. So एक तो हो गया high melting and boiling points, and then it's going to be very very soluble in water. So the reason for that, for both of these things, is that is hydrogen bonds. They can form hydrogen bonds, which are very strong force of attraction. So, and you might be asked to draw one. So a hydrogen bond is this thing that it's if I have an alcohol, the H is going to be very strongly positive because the oxygen is very electronegative. So the oxygen is going to have a very strong negative charge. So if there's a water molecule around, the water molecule is also extremely polar. So the negative part of the water is going to be very strongly attracted to the alcohol or H positive. So they're going to get very strongly attracted to the alcohol. अच्छा, उसके बाद ये कि उसके बाद ये कि और क्या properties हैं इसकी. That's pretty much it. ठीक है. They're not acidic or basic, and so the rest of the stuff is acidic वाला मैं बाद में discuss करता हूँ. So you've got three types of alcohols. One is a primary alcohol, then you've got a secondary alcohol, so what's a primary alcohol? A primary alcohol is going to have just one carbon chain attached to the carbon that's bonded to the OH. Okay, this carbon is known as the alpha carbon, okay, the one on which the functional group is attached. So that's your so that's a primary alcohol. Similarly, you're going to have secondary and tertiary alcohols as well. So we're going to have tertiary, and then you have secondary, and then you have tertiary as well. Okay, the only difference between the three is the secondary कर लेते हैं. So this one is secondary. Now the secondary one is going to have it's going to have two carbon chains on the alpha carbon atom. So it's got another carbon chain. And then finally, you've got the tertiary one, which is this one that it's going to have 3 carbon chains on all sides. So ऊपर भी carbon chain, नीचे भी there's a carbon chain. ठीक है, so you've got primary, secondary, and tertiary alcohols. ठीक है. अच्छा, primary, secondary, and tertiary alcohols. ये clear है? Primary, secondary, tertiary alcohols.
जी सर.
Yes.
एक सेकंड रुकना. पता नहीं क्या हुआ. अच्छा, primary, secondary, and tertiary, and the reactions will kind of very slightly differ. तो वो सब ना फिर हम कल ही करते हैं. बाकी फिर वो reactions पूरा start करना पड़ेगा. So we up till alcohols we'll probably finish this. कितना रह गया हमारा? Look at the chart. अच्छा, so we are actually this part now. ठीक है, we're actually done with most of this stuff. ठीक है, we're done with that. तो ये वाला जो part है ना, ये फिर ये एंड वाला पार्ट ही रह गया. ठीक है, अल्कोहल्स वाला एंड दिस एल्डिहाइड्स एंड कीटोन्स. ठीक है, तो हो जाएगा मेरे ख्याल से इस वीक. चले, ठीक है, सारे कल पे कंटिन्यू करते हैं. ओके,
अल्लाह हाफिज.
Thank you, sir.